a participant too. So we got
Cats there.
Cat's probably there. Let's see. I see pages there. So okay, folks. Can those of you, at least one of you out there in virtual land, let me know whether you can see the screen, because I've got the screen up already.
We can see the screen.
Okay, great. And so that's good to go. Okay, few housekeeping things that I just want to walk you through. I assume you all got the email, I think it was on Wednesday, from Kumar, when we adjusted the what's going to be on the Mondays left in the semester. The first Monday after break, Lisa Ramaker, we've made a video of her. She is our state inspector for the pilot plant, and we are our fully inspected food processing facility by the state of Minnesota. And Lisa has always come in and done a in-person, but this year we thought that wasn't going to happen. So she's going to walk you through how the state ensures, and this is a process used nationally, if not internationally, how to make sure that the pasteurizer, when you say it's 161 degrees Fahrenheit for 15 seconds, how do you know that? So she's going to walk through what they do to check our pasteurizer on, I think it's an every 3-month basis. There's a rotation. So she'll walk us through that. That's, I think, about a 35-minute video. So I'm not quite sure if we're just going to send it out, let you guys look at it, or what from there. It used to be we'd be in the pilot plant and we'd do other things with it, but we just don't have that luxury, so to speak, this year. The other thing, Lisa is also the superintendent for the cheese contest in the state of Minnesota. So basically, if you go to the state fair and you see the blue ribbons on the cheese and butter, she's the one who made sure everything was done by the book. I'm one of the judges. Tonya, who many of you have had in class, is also one of the judges for the state contest, although she's now gone. We're looking to train Ray and Mitch, because we're down to 3 judges left that do it. And one of those guys drives in from Eau Claire, Wisconsin to judge. So trying to find a few more judges. So, and then the week after that, Kumar will do his lecture on alternative processing. Then we have the project and the lab presentations. My plan is, for those of you that when you turn in your processing draft or project draft, I will try to mark it up with my comments, scan it, and get it back to you, hopefully no later than late next week, so that you've got it once you come back to school. Also, your 5th lab is due next week. And as soon as I have all 5 of the labs for each of the laboratories, I will send out those 5 to the group that will be assimilating the information to present at the lab presentation day.
So next week of class, or next week as a?
I would prefer there was a question here about what I meant by next week. As soon as I get all 5 for 5 labs, I will send them out.
Okay.
The sooner you get them in, the sooner I can get them out to you. But I'm going to wait until I get them from everybody rather than one group gets advantage. But the labs technically would have been due Monday or Tuesday of next week anyway. So if you need to wait, if you can't get together as a group, certainly get them in the Monday or Tuesday once school starts. So that still give you quite a bit of time. What we expect you to do with those 5 labs is to look at the variables and compare them and so forth. For those of you that you've all done the membrane lab already. Membranes, we did 5 different products. We did whole milk, skim milk, a 5% whey protein isolate, a 5% 30/60 corn syrup solids, and then a 2.5 of WPI and the 10 DE. different emulsifiers were used in the homogenization lab. So it's really looking at those items. When you start to prepare your report for especially the oral presentation, remember everyone did the lab. So you don't need to take us through in immense detail all the nuances and steps. If something went wrong in some, in some situation, we had the scale go out with one of the groups for membranes. It didn't make a big difference, but something like that, just you want to make sure that you note it when you do the oral presentation. And hopefully you noted it in your written report so the poor group that's putting it together will go, this data doesn't make any sense. So that's something we'd like you to, to do. Typically, we're looking at no more than about a 15-minute presentation for both the processing project and the laboratory project. When we've had 10 groups, it got really long if people started running long, but we will try. So roughly in that 12 to 15-minute range to hit the high points and so forth. It's really to educate your classmates on the different products that you've made, as well as to educate them on what we saw for the variables, because each one of you did one variable for the laboratory. Now that you could see the difference and what difference, what do you see different when you do whole milk versus skim milk? Probably should be slower with skim. You get less flux with whole than skim because you got fat to plug it up. So things like that for people to look at. So that's sort of the lay of the land towards the rest of the semester. What I plan to do today is I believe this is the same cottage cheese presentation that I sent out to you a couple weeks ago. What I want to kind of go through it with you so that you get a lot better feel. Now that you've mucked around with your project, you're at the point of writing your written report, your draft of it, which in essence will become the template for your oral presentation to look at, so you don't underdo things or overdo things, so to speak. So that's really the point of things today. And I'll kind of walk you through what this group did. I believe this was from a couple of years ago, but it's very similar. I picked the cottage because it does have a little bit of complexity that would be somewhat the type of thing that the people doing yogurt and ice cream ran into, because they've got multiple flavors. Here you have multiple fat levels and so forth, because cheddar's cheddar, fluid milk, you had some variation in the fat levels, but not nearly as much potential changes in the processing and so forth. So this is what the group was given as their task, just like you guys did. They're going to produce a full line of creamed cottage cheese, and it's distributed this way by container and then by product type. So there's three different container sizes, 4 different product types, plus an additional type being dry cured cottage cheese, stuff that most people don't eat directly, but you would think, what do you use it for? If you don't have ricotta, some people like to make lasagna with dry cured cottage cheese rather than ricotta. So this was their task, to do this on a daily basis. Assumptions, and this is something for all of you to think about. I would encourage you to assume, even though you're saying that's not realistic, assume your plant is 100% efficient for no other reason than if you make it 95%, then you've got to adjust everything in your calculations by a loss of 5%. And I guess you'd be out of business. If you lost 5% of your product, I don't think you'd last very long as a company. But so 100% efficiency, the assumption of 3.8% raw milk is what is coming into your plants. So you need to think about how much 3.8% fat milk do I need to separate into, do I need extra cream? Do I need extra fat? And so forth. For most of the products you guys are working with, fluid milk will generate extra fat or extra cream because you're reducing down even your highest fat product. Ice cream, you in essence have to go up because you need more fat. Cheddar cheese, cheddar gets it easy because they can make the assumption that they're not going to adjust fat and just put it in the vat. They already know this. So yogurt, again, you're adjusting. Non-fat dry milk, very obviously. You create skim, you create cream. The cream goes through the wall to the butter plant. So things like that. They're assuming here how many pounds of skim milk they need for pounds of curd. So they're assuming they need 100 pounds of skim milk. And with that, they're going to be able to produce the curd, which would be the comparable to dry curd, roughly 15.5 pounds. And they're using a dressing to curd ratio of 50-50. What is dressing and what is curd? The curd is the dry curd, which we'll talk about that processing, but then they need to add the cream. This is creamed cottage cheese. And dressing is the industrial term for the liquid, which we'll talk about in a little bit, that they're putting on. So they, in essence, have two streams they create and then bring them together at the end. The next slides here deal with some compositional things. Here they're giving the composition, which I asked from you guys as well. There are 5 different products. What is the base composition? The moisture, protein, fat, carbohydrate, which is in their case mostly lactose, if not all lactose, and some ash or the minerals component. They make a note here that 80% is the maximum amount of moisture, or is how much water you can sell the public. Similar to some of you, especially the ice cream people, they can only sell so much air and so much water, otherwise they're in violation. You know, like I think I've said maybe to this class, what's the first thing you want to sell as a food processor? Air. What's next? Water. After that, whey and corn syrup, I think is what's next, but all depends. The next slides, they just basically walk through each of their products. In other words, how much curd do they need? How much skim milk do they need to produce how many pounds of curd? Then how much dressing are they going to add? So they're really breaking that product down into the amount of ingredients they need for curd plus the amount that they need for the dressing. Dressing, again, being, you're thinking, why is the fat so high? Remember, they're going to put this in with curd and there's a dilution effect that's going to take place. They're also diluting it with skim milk and the salt amount. The 2%, again, in this case, they have to add locust bean gum and carrageenan. They need something to thicken, is the reason for adding that. Same again, when they move into the 1%, they chose to add a little bit of whey protein. Again, some of these are some subtle differences in here because of the ingredients that you look at. In the case of the products you guys are making, it's really the ice cream and yogurt people that had variations because of flavors and all kinds of things, whereas milk is pretty much milk. Hit the fat, add some vitamins. Cheddar cheese, throw some salt in. Non-fat, get rid of everything. Get rid of the fat, get rid of the water as much as you can, and away you go. The non-fat product, you notice with the non-fat product, no cream because it is non-fat. And they bump up their stabilizing agents to build viscosity in the liquid. And finally, the dry curd is just that, curd. So How much cultured skim milk? It's 100% cultured skim milk. They estimated they needed 500 pounds in order to get the quantity that they needed. Please don't agonize over the calculations. As long as the calculations are reasonable, very seldom do I go, unless they really look like, woo, what a weird number they came up with. Then I will sit down and do calculations here. Are you guys really sure on this? But otherwise, don't agonize over it to any great extent. And then finally, they made a composite of what they needed. How much raw milk, how much of this turns into skim and cream, the various other ingredients that they need. In their case, cultures, salt, stabilizing agents, and packaging materials. So what's going to be made into the product and the package that it's going to go into. Now we'll move to the flow diagram of the cottage cheese manufacturing. And again, you want to, in all of your cases, I think all of you had in this last time I looked at them, really pretty good flow diagrams, because that's your tree that you're going to build the other components off of. When you look at resources, when you look at energy, when you look at CCPs, QCPs, what are the items that build off of that? Okay, fairly straightforward processing here, at least initially, very similar to all of your guys' products. You receive the milk, you store the milk, probably not for too long a time, but you do need to have some storage. You can't simply take it from the truck to the separator and start processing. There might be a day when you're really screwed up in the plant that you'll do that, but normally think of those receiving tanks of raw milk as sort of a buffer. They're the initial starting point from which you're going to flow. Some of you have processes where you need to have, I use the word buffer tank, not buffer in the sense of a chemical buffer, but as a place to store product that is partially processed. For instance, the people that are making non-fat dry milk, they produce the skim, and then they run it through either membranes or certainly an evaporator. They need a place to have a reservoir of pasteurized skim milk prior to going to the evaporator. They can't this equipment can't be timed that close, that you can run one to the other to the other. You can get the pasteurizer, homogenizer, and separator to work that way. But when you have other types of equipment downstream, you need to have that flexibility, buffering, reservoir, whichever term you want to use. In this case, they take that reservoir of milk, they run it through a separator to produce skim milk and cream. If you notice, the cream isn't being pasteurized here, the cream is going off. That would be the one comment I'd make on this slide. Just put an arrow that says cream to dressing, but it shows up very soon. You pasteurize the skim milk, and then you cool it. Typically, when you're making something like a cultured product, once you run it through the pasteurizer, if you have the tank capacity, which you normally would for cottage, for yogurt, probably for, and certainly for cheddar as well, you run it into the vat, and the cooling there is minimal. For instance, if you go up in our pilot plant, we have a cooling section on our pasteurizer. It's not hooked up because that pasteurizer is used to pasteurize milk to make cheese. So why cool it down to 40 to have to heat it back up to the low 90s? So it's designed to skip that cooling step as part of the processing. But if you're in the fluid milk business, ice cream and others, you're definitely going to need to cool it down. So They've cooled it to the set temperature. At that point, they're adding their cultures. If you notice before, they use DVS, which is direct vat set, which is one of the decisions. If you're making a cultured product, you need to decide, do you buy the cultures already made as a concentrate? These are frozen concentrates. And then just drop basically a puck of the stuff into the vat and let the culturing take place. If you're a very large operation, you probably will have a separate room where you will take your own milk and create your own starter because it's cheaper. Rather than buying all these commercial, you'll buy those commercial direct vats, but you'll make your own and then pump that in. So that's just one of the things I would say the cheddar and yogurt people might consider, depending on how they feel about their volume. So we've added the cultures. Cultures are going to be in there for a period of time. We'll talk about length of sets a little bit later, but this is the setting stage. The bacteria are just hanging out, producing lactic acid, dropping the pH of milk from roughly 6.7, 6.8 down to the coagulation point of around 4.5 to 4.6. The isoelectric point of casein, neutralize the charge, they stick together. Same thing that you're doing in the yogurt making process. Cheddar, different. You're using rennet to do your destabilization. Once the vat is set, that has reached the solidity that you want that gel, you go through the cutting step. That is, you use what are called knives, which are really big racks with, I call it piano wire on it. You pull them in one direction, you pull them in another, and you cut cubes. So you cube this 20,000 pound cube of skim milk into small cubes. And depending on cube size, you're either going to be making small curd or large curd cottage cheese. After you've cut, they use the word healing. The reason for healing is you need those curds. Once you cut them, the whey starts to drain out. If you start to do too much manipulation, you will fragment these curds. You need these curds to, in essence, it's kind of like getting a cut and then getting a scab on it. You want consistency on the outside. Once you've got the healing done, you go through cooking steps, because really what you're doing here is you're de-watering that curd. Think of these little curds that you've cut, these cubes, as little pieces of sponge. And as you squeeze them, and the squeezing, because as you heat, they start to squeeze together, the whey is exuded. Same type of thing that you will do for the cheddar making. Whey is what you see when you scoop a cup, especially of plain yogurt, and you get the yellowness there. So you're getting that, you've got little Miss Muffet going on here, curds and whey that you're creating at this point. The healing, then we go through the cooking step, would help shrink it. Eventually go through the whey drainage step. So you drain the whey off. In the case of cottage cheese curd, you actually go through washing steps. You add cold water, does two things. One, it rinses off any residual lactose and so forth off the surface, but it also starts to cool the curd down. You want to get from 90, 95 degrees, if not higher after cook. You want to get down to 40 degrees when you put the dressing on, because you want it at 40 or lower when you put it into your storage facility. It's a lot cheaper to do your heat removal here, if you could even get the heat out in a large cooler. So you drain the whey, wash it, and you have this drained water going off to the side. Now, often in other rooms, we'll see when we look at their floor plan, they're preparing the dressing. Basically, they process the dressing by mixing together cream, skim milk, and the salt, the stabilizing agents, everything but the curd. If you remember back to their ingredient itemizations, it's all of these other things. They're mixing it together. They pasteurize and homogenize it. Remember, this was raw cream, raw skim. Cool it down. That can be done coming off your pasteurizer. Then use a mixer where they're able to mix the curds with the cream dressing, and you have your cottage cheese. So you'll have some kind of a little gentle mixing. You don't want to slosh it around, but you put the curds with the dressing and away you go. Put it in the package and it's ready to go into storage. This is an example of a floor plan. A few things that I would maybe do a little different. One thing they don't show on here is any sanitation points where you have hand washing, foot sprayers, things like that. If you just note that they will be present in appropriate locations, I'm happy with that. Otherwise, people have asked how detailed do these have to be. This one's actually a fairly detailed one because they start up in the upper left hand corner. They've got their storage tanks. So their milk comes in, goes into storage. They take it through the separator. They're giving the size of their equipment in here. They pasteurize. From the pasteurizing, they are going it into these cooling vats. You may or may not need these. Again, depending on, they chose to put them there as a reservoir, but you could conceivably, I'm thinking more of the cheddar people, the yogurt people, pump directly from the pasteurizer right into their cheese vats. That's the 5 rectangles there. In there, they let the bacteria grow, set the cheese, do the cooking steps and so forth there. They have cooling water. They've chosen then to run it through a wade drainage belt. Some people drain in the tank, some people don't, but they're using this fairly large operation, basically a perforated stainless steel belt. The liquid runs out. Meantime, they've got the dressing made, mix them together, put it in the filling machine, pack it, put it in storage, and away you go. So that was their process here. The one thing that they did do that did a nice job is their raw milk storage and their pasteurizer sit in one area. And in essence, that is raw side. And a lot of plants, the people that work there do not go into the other side because this is where you have raw milk, potential pathogens still in the milk. Once it goes through the wall, it's then at a point where it is pasteurized. And that's a demarcation you make with your pasteurizer in any product. Raw side, pasteurized side. You don't use pipes on the raw side and the pasteurized side together. You don't even clean them together. They should be separate entities. You break a connection at the pasteurizer for the raw side, you break a connection on the other side, sanitize your pasteurizer independent. And it does need specific cleaning because you've got a number of issues with burn on and so forth, but you don't cross over. Crossing over is something that gets you into trouble. You guys are all too young you may have heard of it. Anecdotally, something called the Hill Farm Dairy in Chicago doesn't exist anymore. Hill Farm was a Jewel Foods, had their own dairy processing plant. All at once they had contamination, salmonella contamination in their fluid milk. And they went in and initially, they had a jumper pipe. They were mixing pasteurized, washing pasteurized and raw side. Okay. Took it out. A little bit later, another set of contaminants in the milk. And then another time they had it. Then people started going, what's really going on? This is an interesting contaminating bacteria. It was resistant to at least 10 antibiotics. Sounds like a lab strain, doesn't it? And it only contaminated every 10 days. So 10 days, 0, 10, and 20 days that they had the problem. And if I remember right, it was only in 2% milk. So this bacteria was really finicky. And then word started to come out. They had major labor strife in the plant. And so it is speculated that someone was contaminating the product. So no one knows. The dairy was shut down. It never opened. They couldn't even sell the equipment in the US. Nobody wanted to go near that because they didn't know what the heck really went on. So lots of cheap, I don't know if it wound up as a big pile of scrap stainless somewhere, but I have other scrap stainless stories if you want to hear them sometime. Okay, quality and safety. Basically here they went through, just as you guys have done, most of you, each one of those steps in the flow diagram, in their case, receiving of milk. They have a CCP, which is the beta-lactams, penicillin testing. They're also doing QCPs where they're doing compositional and microbial load. There isn't a standard here, but what they're doing is, hey, we want good milk coming in. And if the bacteria starts getting too high, we don't want to buy it from Farmer Jones. We'll go buy it from Farmer Johnson because we want milk that doesn't have bacterial load that will potentially, because remember, pasteurization doesn't kill everything. It kills pathogens. So what they want to do is keep that low so it doesn't grow when you're fermenting and so forth. And they're doing titratable acidity to check again as a quick check. If the acidity is too high, that means maybe some bacteria grew. The plating results are going to be after the fact. Hold the raw milk. They've designated it a CCP, maybe a little strong, but I don't disagree with them. They want to hold it at 35 degrees or less, certainly less than 40. And you don't want it for more than 2-3 days because, again, of potential bacterial growth. Separation, you need to skim it down because you don't want extra fat in your curd later on. Pasteurization, very obviously, the critical control point, killing off the pathogenic microorganisms that are potentially there. You don't want to get to too high a temperature because if you get to too high a temperature, you will induce beta-lactoglobulin, one of the whey proteins, interacting via a disulfide bridge with the kappa casein. And you may think, well, what's the big deal? Well, this whey protein is like putting a big float out there. And so it's going to be very hard to get enough acid. And if you do, to neutralize enough, the charge enough that these caseins are going to stick together. They're going to become a nice firm network. This is something you got to be real careful of in some other dairy products. I don't think any of you guys are working with it necessarily. Ones that'll give you grief in that respect. And in some cases, like evaporated milk, you try to induce it so you don't get what's called age gelation. You want these proteins to have to stay away from each other. So they're really concerned here about the quality of the curd down the road. They want nice, tight-knit curd being produced. Coagulation, there's what's called long set and short set. Long set takes longer at a lower temperature. Short set, most people in large operations will probably do short set because they want to turn their equipment over multiple times in a day. I worked for a company that we did long set because we only made 3 or 4 vats of cottage cheese a day. We put the skim milk in the vat at 4 in the afternoon, put the culture in. The cheese guy, the cheesemaker would come in and start processing and doing the cutting, cooking and so forth about 3 or 4 in the morning. So that when the rest of the crew came in, they were ready to put cream on it. And so really 15-hour process. But short set tends to be one, and in this case, they're dumping a little rennet in to enhance the quick gelation, the quick set. occurring. You want to make sure you've got the right types of cultures, so don't buy the wrong cultures. Anybody doing products with cultures, you have to be aware of something called bacteriophage. And if you have bacteriophage gets into your cheese milk or your yogurt milk, it kills the bacteria. And now you've got a tank of liquid crap that you got to pull the plug. So not only do you lose the product, but now you got to pay the sewer district because you dumped a lot of biological oxygen demand down it. So you need to get the right type of cultures. And this is where you work with your culture supplier and so forth. You want to have a nice uniform temperature during your cook steps and stuff, right? Draining that water, squeezing that water out appropriately, and get that pH down around pH 4.6, 4.8. Some of you who eat cottage cheese are thinking, well, it's never that acidic. And it isn't. Because remember, we still have to add dressing to it. We do the cutting. You can read this again, depending on the size of curds that you want. They mentioned for large curd, small curd, and so forth. You get a more surface area. And again, you're dewatering, so it works fairly well there. Healing, 10, 15 minutes. Some people like longer, but again, you're allowing that skinning, that thickening of that surface so that when you start to stir and you start to scald that milk, the curd doesn't fragment. If you look closely at cottage cheese, you almost always can see little fragments. The term in the industry is shatter. It's shattered. And you really can't make it without a little bit. But if you put a lot of nice thick cream on it, it's kind of like putting paint on cracks on the wall. It hides them from you. The cooking step, again, you're going to kill off the starter culture with this. You're raising up to 120, 130 Fahrenheit, so you're not killing it off. You're also dewatering, tightening up the curd. You do have constant stirring going on because if you let them settle to the bottom, they use the term matting. You've all probably had cottage cheese. If you're a cottage cheese where you got something about as big as your thumb, a big chunk, well, that was because there wasn't good mixing going on. And you're going to look for the elasticity, just some things that they'll take a handful and give it a squeeze and see what's happening, stuff like that. Shouldn't throw it back in though, throw it in the trash. Just looking at good curd and bad curd, if you notice the left-hand side, you got nice, properly formed curds. The other side, they're kind of squishy, mushy, so not what you want. The draining, you need to make sure you get the whey drained away. You're going to do multiple cycles, as I said here, 2-3 cycles. Eventually, this water is also going to cool things down, and you can reutilize that water potentially. Sometimes you'll use the last cold rinse as the first rinse on the next batch because it's not really that full of stuff yet. So you can work with it that way. Now moving to the cream side, the raw cream has to be pasteurized. They're going to 177. Again, you could get, and again, cream has to be pasteurized higher than milk because fat protects the bacteria. You need to homogenize so you get a nice even fat distribution. And you add enough cream to skim so that when you mix the dressing with the curd, you dilute, your dressing might be, if it's 50-50, and you want 4% fat, well, you mix it in ratios, the right ratios in order to get the fat to be 4%. Typically, what the regulators look for is when you start talking fat level, unless there's like cheddar or ice cream where there's this minimum, whole milk 3.3, or it could be greater. But if you say 2%, it's 2% plus or minus a tenth is what they're going to look for. Too high or too low, you're not giving the consumer what you say you're giving them on the container. The same would be true of yogurts and so forth. Ice cream, again, you meet that minimum for vanilla of 10% fat. You can go higher. Can't go lower. You're not supposed to go lower. Unless you know where there's a state that doesn't check real well, then you can ship it there. There is a state like that, but it's not a very populous state, so you can't sell that much there. Packaging, again, daily coliform, total plate counts, probably yeast and mold I would have added here, because you probably have had cottage cheese where it gets, I call it blue, get little blue specks in there, you get some mold. Typically, when I worked in the plant, we did yeast and mold as well. Maybe the plants are cleaner than they are. We're in the 70s now. Storage, you want to keep it good and cold. Shelf life, typically 3 to 4 weeks. You can get a lot longer. The shelf life can be longer and it still meets bacterial quality standards. But if you let it sit too long, it starts to develop off flavors, such as what it absorbs and so forth. Resource evaluation, this is kind of what I'm thinking from you guys. Your processing step, what is the energy level? Rated on a 1 to 5 scale. I don't expect you to calculate how much energy you're using based on this or that. I did have a student a long time ago when Jody was with us. She was also a chemical engineering major, so she wanted to do all the calculation. Yeah, I know a couple of the people here in the room are giving me this, huh? She wanted to calculate it all. Exactly how much energy it take at the pasteurizer per 1,000 pounds of milk. But it's just to make you think about the steps. The resources here would be the cold water, those types of things. I didn't see somewhere there should be a key with respect to what the initials mean. A waste generated is mostly wastewater. They're calling excess cream a waste stream. It is relative to your product, cottage cheese, but it may not be a waste stream in the butter guys. If you're making butter, the skim milk's the waste stream. So, but again, you might want to call it surplus product that you can sell. They just keep going through all the steps here. A lot of ones. One tends to follow a bigger range. Scalding, the only big one here, simply because you got to add energy to heat things up. Moving into the dressing prep, they've got homogenization, number of unit operations, which will use energy. Some waste streams. The solid waste here you need to think about, and they're indicating packaging, and that's true because you've got cardboard boxes that will have packaging in, or some types of things that are used unless you're totally making your packaging on site, which is possible for probably only the fluid milk people if you blow mold all of your own packaging, but you'd have some bad packages and so forth. And then just the waste streams, the acidified whey. Acid whey is tough to get rid of. It's not the stuff that you can make money out of by making whey protein isolate, because the pH is down around 4.6, whereas cheddar cheese whey is going to be in the 5s, much easier to work with, much easier to separate. So acid whey, I've seen proposals where people decided to use acid whey to put on alkaline soil to try and reclaim soil out in some of the Western states. So it's also been used, you can imagine how much it smells in the spring, been used, dry it down and use it as a road salt substitute. You got all this protein there. You've got the extra cream, which they're given to the butter, sending butter, wastewater from cleaning, all the different solid waste. bad product you could incinerate. The other thing, again, that might be something you could, again, the trouble is it's in a package. If it was more bulk, you might be able to utilize it for animal feed somewhere. And finally, that was their questions. So that's really does that help people get a handle on what the presentation will look like? And really what you're doing, think of it as a play. Your written draft, which becomes your written final product, is the script. And what you're doing here is presenting the play, so to speak, what is in that script. So that's what I had for you today. Anyone have any questions? Otherwise, you can certainly, again, I would really encourage you as you're writing your draft, say, what do you think about this? What do you think about that? The more questions you ask, the more I can help you and the stronger your finished project would be. Truthfully, if you don't want to turn in a draft, go ahead. But then you're living with me only seeing something I'm going to be grading. So I had that instance in one of my classes where Science of Food and Cooking, 117 students and 22 of them chose to not turn in their projects, the project drafts. They can still get help, but they have to make a personal appointment and come into lab when we aren't having lab to visit with their TA who grades it. So I will shut up there, and if you have questions, feel free to ask, or like I say, you can email them to me. If I know I've met with off and on with different groups, maybe not the whole group. We can certainly set up a Zoom at some point if you want to visit that way. I'm with you. I don't think I lecture the week right after break, but I believe there's 2 weeks in there that I'm doing things like wastewater and sewage and those types of things. So I'll be coming for lecture. If you want to set up a time as a group to get to, a couple of you come in. I met with one group. I thought there was more than one coming. We can set up the main office and spread people out up there. I was sitting there waiting, and the department head walked in, and I said, well, I'm meeting with a group. And then he looked around, and I kind of got that nod, like, you did it right, because I had chairs about 10 feet apart all around the surface up there. So with that, I'll let you guys go. And people, again, if you have questions, feel free to ask. Otherwise, enjoy your